So this is our core maths memory card. Let's get this card out and write your templates on your revision card. We're going to show you circle theorems on this maths memory video. This is grade 6 to 7. This is a silver topic. We are now week 11 on the revision planner. You download that from our website. The sample one that is, and let's go through these key objectives. So the first thing I want to show you is this, the 8 circle theorems. Alright, I'm going to show you that from scratch in the back to basic lessons and how to apply this in context to exam questions, sometimes involving an algebraic context, i.e. with x in it. So this is circle theorems, as we said. And 6 to 7, create a space for your best examples on your revision card and 3 spaces for step 1, 2 and 3. Hopefully we can show you that by the end of this video. Let's turn around for our toolkit. Let's create one big space on our toolkit. This is where your best methodologies and tips and tricks come into play. We're going to show you 8 different circle theorems and then names of them as well. So you can identify this along with your key features in this topic, which means how you can instantly identify what circle theorem to use. Anyway, keep it one big space here. Press pause and press play when you have finished this. Question 1, back to basics. Press pause. Let's write these 2 circle theorems down and press play when you have got the answers. Now, in all these back to basic questions on circle theorems, we're going to be showing you all 8 theorems, and these 8 theorems you need to master for the core questions and in general for your exams, because they won't be giving you any formula sheet on these. And to help you to understand these 8 theorems quicker and more effectively, we're going to be introducing you to a keyword called key features. Okay, and key features simply mean what circle properties can you identify straight away without even reading the question? What pops up in your mind when you see a question? And these will help you because sometimes we have lots of circle properties on a circle question and lots of maybe 2 or 3 theorems in one, and students get confused into the wording and into the question. Don't look at the question or the words, just look at the circle and let's look at the properties that pop up initially in our mind. Okay, so that's key features. So AOB is a diameter, center 0. Points A, B and C are on the circumference. Angle ABC equals 32 degrees. Let's find out X and let's give a reason why. Now, here a key feature is going to be the diameter. The diameter over here is AOB. All right, so we're going to put a little key over here and we're going to call this key feature because that is straight away coming to us as a circle property. Nothing really else pops up. Now, once you know this diameter AOB and center 0, it's got to go through the center, obviously, any diameter. We can think, what theorem do we know about this? Now, this happens to be something called the semicircle theorem, because any time a point touches the circumference, which happens to be C in this case over here, this will form 90 degrees. That's something you should definitely know from a semicircle theorem. So hence, we've colored this in green, and this will be 90 degrees. All right, a little symbol over here. Now we just go back to finding out X. This is a triangle. All 3 angles in any triangle add up to 180. Hence, we could say 90 plus 32 will give us 122. And hence, 180 take away 122 would give us 58 degrees. So X would be 58 degrees. The reason why, semicircle theorem. All right, now the reason for every question, you could try to put some key words in each one to make it look reasonable as your answer. Okay, it doesn't have to be fixed in stone, but semicircle theorem will be good enough for this answer here in maths memory. Question 2, AOB is a diameter, center 0. Points A, B, and C are on the circumference. Angle ABC equals 67, so ABC. Let's find X, Y, and Z. So again, key features for this. So key features, we definitely could see the diameter AOB. This is a key feature going through this. And also a second key feature, we're identifying 2 radii, the plural of radius. Okay, AOB and OC. So those 2 things should pop up straight away in your head, and then we can go, what do we know from this? What theorems take us to those key features? Now let's find out angle x. So x is over here. Well, this two radii are the key properties of any kind of isosceles triangle. So if we had an isosceles triangle over here, for example, these two would be the same, and those two lines would be represented by the same points as this, the green parts on the circle. So this would be O, B, and C. That would help you make it more sense. You can always write these separately, it will help you. That's 67 degrees. So if this is 67 degrees, a key feature of any isosceles triangle, this would be the same as well, 67 too. So x would be 67 degrees. The reason why, well, two radii, if you see this, will always form an isosceles triangle. We'll just write the word isosceles triangle over here. But obviously, as we said, you can elaborate on this in the exam. Why will this be this angle over here? Let's say BOC. This would be simply be all three add up to 180. So 67 times 2 is 134. And 134, take away from 180, would be 46. So this would be 46. That's because angles in a triangle rather equal 180 degrees. Z, let's work out Z. Now Z, this is a straight line. So simply it'll be 180 degrees, take away Y, 180 take away 46, 134. Straight line. All right. That's enough for that. All right, so we're getting you used to how to tackle these circle theorem questions. The key elements are key features that will lead us on to the 8 theorems, which you'll need to know as well.
Question 3, back to basics. Let's look at these couple of questions over here. Write this down and let's try our best to answer both these questions. Find x. Press play when you're ready. So O is the center of a circle. ABC are points on the circumference of a circle. ACB equals 90 degrees. What are our key features? Well, over here we see a center angle over here and a point of the circumference. Circumference. Right, what can we find out? So basically this is the double angle theorem because the angle at the center is always double angle at the circumference. We see an angle over here. This is the center and this is the circumference over here. Now we have this imaginary chord, we call it here on maths memory, and this is something they never really give in the exams, and this is the imaginary chord AB. And from here, AB, there are two clear triangles emanating from this. You can see this quite clearly. Your first one is this, look, AOB, and the second one is ACB. So basically AB acts as your base, let's say line, on both these triangles. That's how you know which one you're looking at. It's this one over here, the center, and this one ACB, because of that thing we just talked about over there. So X is clearly going to be, let's say, double this, because we're working backwards. Double 1938, we'll call it a double angle theorem. It's always a good idea to write this imaginary chord in red as well, wherever you see this. In fact, let's just write this little key over here to make it better for yourselves. This is your imaginary chord. All right, so again, in your notes, you can write this down. Imaginary chord. Right, this one over here. So ABCD are points on the circumference of a circle. ACB equals 22 degrees. So key features, straight away, we're going on to our circumference over here. We have ABCD. Now, we have X. What is X? Now, again, let's look at this. Key features are over here. This doesn't have to be in the center of the circle over here, and it doesn't say 0, so it isn't really O in the middle. What we'll do, we'll just put our little chord over here, and this is quite similar to the theorem above. We have two triangles clearly emanating from this baseline over here. So the first one is this one over here, which is ABD. And the second one is ACD. All right, so we have 2 points hitting the circumference at B and at C. The one before, the double angle theorem, was center and circumference. This one is called the same segment theorem, and it's circumference and circumference, so the other C. If you think about it like that, they're both the same. It looks like a butterfly. That's how we identify this over here, or whatever you want it to be is 22 degrees. It's worth saying as well, these two would be the same as well. They are called y and y, and these would be vertically opposite as well. Z and Z. Reason why, same segment theorem. Okay, and the reason why is because this forms a major segment. Anything above AD is a major segment. Anything below AD is the minor segment. So hence B and C both fall in the same segment, which is the major segment over here. Hence same segment theorem. Question 5, back to basics. Press pause. I'll write both these questions down, 5 and 6. Press play when you're ready. Now O is the center of a circle and ABC is a tangent to the circle. So we have O and a tangent here respectively. So again, key features, what do we know about this? Well, when radius meets tangent, this is very, very easy by the way, it obviously makes a type of angle. This angle has got to be 90 degrees, okay? So when radius meets tangent, 90 degrees. The name of this, I will just call it radius meets tangent. Okay, quite easy. Question 6. So any key features from here? Let's have a look. Now we have, let's say ABCD are points on the circumference of a circle. DAB is 102. That's 102. Circumference, what do we know about 4 points? Specifically 4 points. These 4 points on any circumference. They form a cyclic quadrilateral. Alright, so there are two things we can gather from this. The first thing of any quadrilateral within a circle are all things add up to 360. Okay, so the sum equals 360 degrees. The second thing you could say, let's say A plus C, I'll give you the answer over here, is 180 degrees. Also B plus D is 180. Okay, so opposites add up to 180, only the cyclic quad over here. So this will be 180 take away 102, which is 78 degrees. And you can write that down over here, cyclic quadrilateral. So here we go. All right, look back at these two, and these are two key circle theorems to build up our little portfolio over here. Question 7, back to basics. So here's another kind of theorem. Let's see what we can identify our key features from this one. So AC and BC are tangents to the circle center 0. ACO equals 30 degrees. So now these are tangents, and this is something, a key feature. And both these tangents, AC and BC, are emanating from a point C. This point over here, O, is the center. And this line is bisecting it, which means it's right in half of this, let's say, kite-looking shape. And the trick is to look at this as a kite, really. If you want to, some more key features over here are two radii, OA and OB. They'll always be the case. So this theorem is called tangents from a point, all right, because they're all coming or emanating from a point over here, C. These will always be right angles, and this will be a kite, OACB. Question is, what is angle X? So X is, where is X?
So here are your 8 different theorems. The theorems you should have picked up during the back to basic 8 questions. We've taken the same questions and put them on here. It's up to you to identify your key features on this, but you should find some similarity or link with these circles, definitely. So press pause, take time to sink these in. We're going to now show you some nice core exam style questions where you can identify these and apply your knowledge from this card.
Question 1, Core 1, Part A and B. Now let's get down to these exam questions and let's focus on trying to put all the 8 theorems, how good is your memory, onto this question. So think of the word key features as well in terms of looking at the question and what pops up to you in your mind, what do you identify straight away from that circle which should link to those 8 theorems. Anyway, press pause, press play when you're finished. A, B, C, D are points on the circumference center O. AOB is a diameter of a circle. CAB is 28 degrees. Now let's look at our key features. What can we see from over here? Well, ABCD, this looks like a cyclic quadrilateral because there are 4 points on a circumference. That could help us. It may not. Anyway, that's a key feature. AOB is a diameter. That could help us. What else? I think that's about it, really. So let's look at the questions. Let's delve down into this. X, what is X? So X is over here. Now this is the center of a circle 0 and this is a diameter. So obviously this is a point on the circumference, point B. This is the semicircle theorem. Okay, so all 3, this plus this plus this, have to add up to 180 degrees. This has to be 90 degrees. This angle over here, ACB, is 90. So if we add up all three, take away from 180, this would be 62 degrees. Again, we'll put semicircle theorem. All right. Again, you elaborate on that, obviously. Y. Now, Y is D over here. Now, Y and X add up to 180 degrees, six cyclic quadrilateral. So X plus Y equals 180. We just said from number 1, part 1 of that, 62. 180 take away 62 would be the answer for this. So this would be 118. And we'll write there cyclic quad for short. Part B. So ACD are points on the circumference, center 0. AB and CB are tangents. Angle ADC is 50 degrees. So we just said that obviously these are points A, C, D. All right, and we have center O, and these two are tangents over here. And that's basically looking at our key features. If you look at this quite carefully, those are key features in these different colors. We could also say OA and OC are the same length, the two radii as well. All right, let's get down and delve into this question. Angle AOC. So AOC is over here. AOC. This little one over here. What is that? Now this, again, center. This is circumference. Two key features. This has got to be double. So AOC, rather, has got to be 100 degrees. Because angle at the center is double. Okay, double angle at circumference, or double angle theorem as we call it. Quite simple. Angle ABC. All right, so from our key features, how can we get this? ABC. So whenever we have, let's say, a tangent from a point over here, this forms a kite. You've got it. Therefore, 290 degrees over here. This, we know, already is 100 degrees. And all four angles of any quadrilateral, a kite being a quadrilateral, adds up to 360. So 90 plus 90 is 180. 180 plus 100 is 280. 360 take away 280 would be 80 degrees. So we write it 80 degrees. Reason why, well, I'll just put a kite over here, but you elaborate on that, okay? 360 degrees somewhere, put that into your answer. Angle CAB, CAB, CAB. So where's this? Now this is going to be an imaginary line. We need to put this over here, in fact, to make it look a bit better. CAB. This is the one we want to find out. Let's make it a different color. Perhaps we'll make it this one over here. All right, CAB. What's this? Now this is quite easy, obviously. This is the one we want to find out because if you look at this, well, there are a couple of ways of doing this, in fact. Let's look at the first way of doing this. So this is 100 degrees. This forms an isosceles triangle. So this must be 40 here, and this must be 40 as well. Okay, that's 40. Can you just about see that? And that's 40 as well over here. This is 40 as well. So therefore, this is 90 degrees. Okay, OAB is 90 because when radii means tangent, it's 90 degrees. Hence, 90 take away 40 must be 50. So the reason could be isosceles triangle and radius means tangent. Or we could say this. I mean, you've probably learned about the alternate segment theorem. You have a triangle over here, CDA. All right, that's a triangle. You got top left, which is 50. Bottom right must be the same. Top left, bottom right. Alternate segment theorem. This must be 50 as well. So either one, you can put that down. I'll put isosceles triangle though if you want to. But also the alternate segment theorem. In fact, let's do both, and you can make sense of either one that makes sense to you. All right, there we go. Question 2A, core 2. So let's look at this exam question over here and let's find out angle X on this. This is in terms of X. So we want to see if you can write this in terms of X rather than just a number. Press pause and press play when you're ready. Now AB are points on the circumference, A and B, at center 0. And we have BC, which is a tangent over here. AOC is a straight line over there as well. Angle ABO is X degrees. Find angle ACB in terms of X. So ACB. It wants you to find this one outside in terms of X. So there are a couple of ways of doing this. Let's look at any way you want to. But it's worth stating that this is not to scale, first of all. And you probably will notice this in a second. Okay, so we'll just write this just so you understand that we can use either of these methods over here. Right, method 1. Now let's look at this. We have two radii over here because we have AO and OB. This is a key feature. All right. What does this tell us about this? It tells us we can use this isosceles theorem to figure out the other angle over here, which is, let's say, AOAB. All right. And this will be X as well. Therefore, this is a triangle AOB. This could be, obviously, 180 take away 2x. So we could write this over here as 180 take away 2x. All right, and therefore we could figure out this angle over here. We could say, all right, we have a straight line. So therefore, what is this angle over here? Because we're trying to find out all the angles in this triangle BOC. So this one would be, let's work it over here. All right, so we have now 180. Straight line this is because take away 180, take away 2x. All right, because it's a straight line. We'll put a little thing over here. All right, this is how you identify this. This is where your algebra's got to come in quite nicely, actually. So we've got 180 take away 180 plus 2x. The reason why, this is imaginary minus 1. Minus 1 times 180 is minus 180 here, but minus 1 times minus 2x is plus 2x. That's a major misconception with students sometimes, okay? This will simply lead to 2x, so this therefore is 2x over here. This over here now, this is a radius, this green bit, and this is a tangent BC. Therefore, we could say that this blue bit over here is 90 degrees. Hence, it's not to scale. That's why we mentioned that at the beginning. All right, so don't just look at this at the beginning and think that's not on the right angle. Radius means tangent. It is 90 degrees. So this is 90 degrees. We have this. We have basically, this would simply be 180 take away 90 plus 2x, which would be the same as 180 take away 90, which is 90. And we're left with minus 1 times 2x over here. This would be minus 2x. So that would be a final answer, 90 minus 2x. That's one way of doing it. Let's show you method 2 of how you could do this question as well. Now method 2, let's go through this second alternative. You could use this. It's probably slightly easier, and we'll show you why this is. Now let's look at the bigger picture. Bigger picture means the bigger triangle. So we have A, B, C. Okay, so the bigger triangle A, B, C. Let's see if we can figure out a basic concept. All three add up to 180 degrees from a triangle. A already over here, or let's say OAB, that's going to be X degrees. All right, because obviously this is an isosceles triangle. B over here, okay, ABC, this would be X plus 90. Because obviously when radius meets tangent, we figured out that this angle is 90 degrees. And then this, we're left with C. We'll call it C if you want to, or let's call it ACB to make it a bit more technical. This should equal 180 degrees. X plus X, let's figure out this left hand side. X plus X is 2X plus 90 plus ACB equal to 180 degrees. Let's carry on. We'll do this in one step. ACB has to equal therefore 180 take away 2X take away 90, which therefore is 90 take away 2X. That should be snap with the method 1 we just worked out. So go through both of these alternatives, make sure it works for you, and these are two different ways of interpreting question 2a. Question 2b, core 2. So again, we're looking into making an angle in terms of x, testing you thoroughly on this. Write these questions down, part A, B, and press play when you're ready. Now, A, B, C are points on the circumference center O. A, B, C. AB is a chord. We can see this over here. AB, going right across. Angle AOB is 2x. Okay, and DBE is a tangent over here. Find angle OBA. So angle OBA, let's color code this. Let's call it green. OBA, this bit over here, that's what you want to find out. Right, let's go through this. So what are our key features again? So key features, we're looking again at OA and OB being two radii, okay? Could be isosceles over here. What else could we see? We can't do a cyclic quad, only 3 points on this circumference. Could be the alternate segment theorem. Well, we're looking at two different triangles, you know. If you look at this, ACB and AOB being two different triangles, maybe we could apply a bit of that. Let's see how we go. So already we've looked at different circle theorems. And one more, in fact. Look, if the center is O, radius meets tangent 90 degrees. That could be one as well. Right, so there are about 3 or 4 different theorems over there. Right, now let's answer the question. OBA. Let's look and see what can fit into our model with those key theorems. So this bit over here. So we have an isosceles triangle. OA and OB are 2 radii. Hence, let's see what this could be and this could be in terms of all 3 adding up to 180 in this triangle OAB. So one of these over here would be 180, take away 2x, and the whole thing would be divided by 2, because obviously we've got 2 x's over there. So that would literally give us one of these. It would give us this one or this one over here. Alright, so this would be literally, if you divide this by 2, it's like say 180 over 2, take away 2x over 2, same concept, 90 minus x. That would be one of these over here. It could be this one over here, or it could be this one over here. The choice is yours. But we'll write this as 90 minus x and 90 minus x. That's part A for you. Right down to the isosceles triangle theorem. Angle ACB. Now ACB, let's color coordinate this again. ACB is this one, ACB. We're going to find out this one over here. So there are a couple of ways of doing this. Let's look at the first one over here, method 1. So method 1, it's saying, now this one, OCB, you should look at this triangle over here, ACB, this triangle, and this is the, let's say, top right of this, and the bottom left would be this one over here. All right, so this looks like the alternative segment theorem to us. That's what we measured as a key feature. This bit would be the same as this over here. You see, top right, bottom left. So all we need to find out is this brown bit on the left. Now this is a radius. We said radius meets tangent. This is 90 degrees over here, and we found out what this angle was in part A. It was 90 minus x. So if we look at this, we have 90 plus, that's 90 degrees from here, plus our answer from part A, 90 minus x. Okay, this has to equal ACB. Okay, from alternative segment theorem, bottom left, top right. Let's just work this out a bit more. 90 plus 90 is 180. That's imaginary 1 times that. And obviously, minus x, 80 minus x would be your answer. So a bit more difficult in terms of spotting that, but you know, not too bad. A second alternative could be this over here. We can use this notion of the double angle theorem. Now this is what we're going to want to find out, ACB. Hence we could find out this over here. This would be double the angle of ACB, okay? This angle over here. We can call it, well, this one over here, yep. So this one, if it's double, first of all, let's name it as this whole circle will be 360. So therefore, this would be 360, take away 2x. So 360, take away 2x would be this. This bit, ACB, would always be half the angle from the double angle theorem. Hence, it'll be half of 360, take away 2x. So we half that, let's see what we get. This is actually quite a simple way, in fact, but it's harder to see. Divide this by 2. Method 2, by the way. This will definitely give you 180, take away x, which is the same snap. So either way, whatever you find easiest, you could do the alternative segment theorem over here, or the double angle theorem on the right over there. Question 3A and 3B challenge. Press pause, write these 2 circles down on a piece of paper. Let's try these challenging questions. Press play when you're ready. Now A, B and C are points on the circumference center 0 of this circle, and we want to find out angle X. Okay, so X is over here. How do we find this out? So this is kind of tricky, really, but the answer is in the question. It's really looking at you. Now, if you look at this, we only have 1, 1, 2 over here, all right? And think of it like this. If you look at this as a circle, you can really see this as, if I just think of it as this roughly, you could probably see this, that was the center over here. Think of these 2 points over here. Think of this point, that, and think of them as just going down slowly like this. Okay, I'm going downwards pushing this A down to here, the C down to here as well. And if I just go up to what the original one was showing us, it looks like this. This is B, and this goes down to here. So this is B, this is A, this is C, this is O, okay, and this is 1, 1, 12, okay, same thing. How would you find out this angle over here? It looks quite familiar because obviously this angle, which is this one over here, would be double this angle over here, the double angle theorem. So guess what? These lines, these red lines, are just pushed up a bit further than this AO and AC. So we're pushing them up to create AO and AOC over here. And what we've got is that this whole thing is 360. 360 take away 112 would be this. Let's write this down. This, as you've guessed, is a double angle theorem. 360 take away 112. We do the maths behind that. You'd get 248. Okay, so 248 would be this green bit over here. So this angle X would simply be half of that. Half of 248 would be 124. To make sure you understand that, that is the double angle theorem. It kind of like looks like a rhombus in a way, but it's not a rhombus, but that's how you would figure this out. X is 124, the same as that one over here. Now let's look at the second question, question 3b. This is a bit more complex. A, B, D, C, or CD rather. These are all points on the circumference. All right, we can see that from over here. A, B, C, D. GDE is a tangent. GAF is a tangent, and FCE is a tangent. Okay, these long lines over here. Find angle X. So the first thing that you should see when you look at this is, you know, your key features. What is staring you along over here? Now the first thing we see is this, let's say, well, ADC. We're seeing a triangle over here, and this is a tangent GDE as well. Okay, if you look at that, that is also a tangent. Let's highlight that, in fact. And this brings us to the alternate segment theorem of this. In fact, if you look very closely, you can see 3 alternate segment theorems over here. You know, all these tangents are the same thing because they hit these points A and C respectively as well. Okay, but we'll come to that in a second. Now, we have this little trick over here in alternate segment theorem. Top left, okay, inside the circle, top left is the same as bottom right. So bottom right must be this one over here. If you can see this triangle, that must be 68 degrees. Now also, if you look at this, there are actually 3 angles that are the same in alternate segment theorem. There's the top left, bottom right, but also this angle would be 68 degrees as well. Okay, because if you look at it and you turn your head around to this tangent, FCE, I know we can't do that, rotate it. This forms the bottom left, and this is the top right of that, if that makes sense. Okay, so there are 3 different angles associated with any alternate segment theorem. This 68 is the one over here. If you look at that, this forms an isosceles triangle because these are the 2 base angles of this triangle DCE. Hence, X must be 68 plus 68. If we double that, we get 136, and 180 take away 136. This will give you the final answer for this. 7, that's 4. This is 4, and that's 0. So 44 is the answer. X would be 44 degrees from that alternate segment theorem understanding. Not as easy as it seems, but again, the trick is to appreciate the third alternate segment theorem angle, which we discovered is the 68 over here. Let's try to find angle Y now. Okay, so angle Y over here. Let's do this one. So angle Y is here. Now again, let's see what we have. Now we're given this 75 over here. How can we use this to find angle Y? That's the question. Now if you understand how we found out angle X, surely we must understand how to find out this one over here, because if this is 75, okay, I mean this, if you look at this A as the bottom, GAF as your tangent, your bottom of your circle, this is your bottom right and top left. Okay, so this angle over here would be 78 degrees. All right, so we've got this over here, 75, bottom right, top left, only because you have to imagine that this is the flat bit at the bottom. That would be 75 degrees. Now, if you look at this carefully, again, we're seeing another theorem over here, your key features. We're seeing something here called the same segment theorem. AD is your chord, and you've got these two bits over here. You've got ACD and also obviously ABD being the same. So this must be obviously the same thing, 75 degrees. If we go into that one over here, that is 75 degrees, which happens to be Y as well from the same segment theorem. All right, so we've seen that. Again, we're getting this from two sources, the alternative segment theorem to begin with, if you turn your head around on that tangent, and then the same segment theorem. So Y would be simply 75 in this case. Okay, we haven't explained it in maths memory in words, but again, you should appreciate what we've talked about and interpret into your findings in the final exam.
So here is your completed maths memory card. It should look like this. Let's go through this quite briefly. So you should know the 8 circle theorems inside out now and how to identify those theorems. You should also know how to apply these questions in context as well. You should have an example here for your best circle theorem during this video. And these 3 steps we've picked up. When you look at a question, identify your key features, which means look at what you know from your theorem so far. What does pop up in your head? Okay, so look at these before you even read the question. These key features should pop up. Is it a radius, a diameter, things like that. Read the question carefully then and apply your knowledge from what you know, those 8 theorems, and then you'll automatically get a result. Some questions have 2 or 3 theorems within them. It's quite normal to have that. So be aware of that, but you should not have a problem if you know your 8 theorems inside out. So let's turn over to our completed toolkit to get you going for our questions, which you can apply yourself in the Let's Do It section to come. So this is what you should have before we start our Let's Do It questions. We should have our toolkit on 8 of your theorems. Make sure you have these jotted down somewhere on your revision card. Press pause. If not, just write these down. But make sure you understand these and your key features of how to identify each one. Once you've got this, we're going to go on to our Let's Do It questions for you to get a chance to apply these into your own way of your own thinking.
Question 1, let's do it, circle theorems. So let's try these questions yourself. Let's put it to action, what you've learned. Let's look at your key features and your 8 circle theorems. If you have them to mind, put them to paper and let's try these questions. Press pause and press play for the answers when you're ready. Question 2, let's do it, circle theorems. So let's go through our cards, let's go through your theorems, and let's identify, more importantly, your key features on this circle. We have quite a few theorems over here to get to this angle BAC. So press pause and press play when you're ready to find the answer. Here's the final question on our Let's Do It questions. So let's pull everything together and let's do this quite challenging questions to find parts A, B and C. Use your toolkit, use your key features and your 8 circle theorems, what you know, to apply to this question. Press play when you're ready for the answers.
Congratulations on finishing the silver topic on circle theorems. So how well have you mastered these 8 theorems? How well do you understand? And how well can you identify the key features we've talked about in maths memory on this video over here? So if you understand it well, if you've clocked those revision cards of yours and your Let's Do It questions are on par, go to your revision planner and let's give yourself a feel-good factor out of 10 and rate yourself on how good you performed on this particular topic, circle theorems.